Question 2. Europium with relative atomic mass 152 grams per mole reacts with dilute aqueous acid in a redox reaction, forming a solution and hydrogen gas. A student proposed 3 possible ionic equations for this reaction, forming europium ions with different charges. Equation 1, this is stoichiometric mole of 2 to 1. Equation 2, stoichiometric mole of 1 to 1. Equation 3, stoichiometric mole of 2 to 3. The student plans to carry out an investigation to determine which equation is correct. Hydrochloric acid is used as the source of H+ ion aqueous. The student's method is outlined below. Step 1. Using a 3 decimal place balance, weigh a suitable container for the reaction. Add about 1 gram of europium to the container and reweigh. Step 2. Set up apparatus for gas collection. Add an excess of dilute hydrochloric acid to the europium. Step 3. Measure the volume of the gas produced, and these are the results. Mass of container, the mass of container plus europium, the volume of gas produced. A. Draw a label diagram of suitable apparatus for this investigation. Well, this is the diagram that I would draw. We got the conical flask, or you might call it Erlenmeyer flask, in a closed system because nothing is going out and nothing is coming in. So it's a closed system. So when the gas is produced from this reaction here, the gas will go into the cylinder. You can measure the gas collected. Or you could pass the gas through a water bath. So when the gas comes in, and that will actually cool it, so you can get the gas and collect the gas here. This is a measuring cylinder. This is the gas collected. That's the gas collected here as well. Part B. Analyze the student's result to conclude which of equation 1, 2, or 3 is supported by the experimental results. Assume that the condition in the laboratory are room temperature and pressure, RTP. We want to try and find the stoichiometric mole, and from that we can then say which one is correct. So the first thing we can do here is to find the mole of europium, and to find the mole of europium we need to find the mole by using mass weighed over relative molecular mass, and the mass of europium collected, because we're going to work that out, is the difference of the mass and the mass weighed, and that would be 0.988 grams. And we need to then work out the mole of europium using that formula. We know that mass, we know the relative molecular mass for europium is 0.988 divided by 152, and that gave 0.0065. Now we need to work out the volume or the mole of hydrogen produced, and to do that we need to use mole is also equal to volume in centimeter cube over 24,000 centimeter cube, or we could use volume in decimeter cube over 24 decimeter cube, but this is what we're using right now because what we've got is in centimeter cube, so we have to use this one, and therefore the mole of hydrogen gas will be 152 centimeter cube over 24,000 centimeter cube. So the unit cancels out. In this case, it's a ratio. So that will give us the mole of 0.00633. So this is roughly the same mole as that one. So that means the ratio in this case will be of europium will be, if you divide that by itself, this is the smallest, and divide that by the smallest, you would end up with a ratio of 1 to 1, which means the correct equation will be the one equation 2, and so we have to write equation 2 here. C. The student repeats the experiment but adds concentrated hydrochloric acid instead of dilute hydrochloric acid. The apparatus gets hot during the reaction. Predict how the hot apparatus would change the student's results and the conclusion in B. Right, so in this case, when the experiment becomes hot, it means that the gas, hydrogen gas, will expand, so a large volume will be recorded. In that case, the hydrogen gas mole will also be higher. The mole of the hydrogen gas will increase, which in turn will increase the ratio of EU to hydrogen gas. That ratio will also increase. And finally, the student will then have gone for equation 3 due to the higher ratio of EU to hydrogen gas. D. The student modifies their method as outlined below. 1.52 grams of 0.01 mole of europium is reacted with an excess of dilute hydrochloric acid. An excess of aqueous sodium hydroxide is added to the reaction mixture. A precipitate forms, which is collected, dry, and weighed. Explain how the mass of precipitate formed would allow the students to conclude which of the equation 1, 2, or 3 is correct. Well, so first thing we have to remember is that the mole for this reaction here is actually 0.01 mole, and the first equation, the EU plus aqueous, would be OH minus aqueous, give you EU OH, and that's solid. And the second one with the EU2 plus here will require 2 OH minuses in order to balance that up, and you then form EU 2OH. Again, that's solid. And you can guess what would happen here with EU3 plus require 3 OH minus aqueous. We then give you EU OH3. Again, that's solid. At this point in time, we need to work out the relative molecular mass. And the relative molecular mass for that one will be 169. That means EU plus OH, that's 169 grams per mole. And that of the EU OH, two of them will be 186. And the EU3 OH will be 203 grams per mole. Well, we know the mole for each one of these. The mole is 0.01, so we can find out the mass. We know the relative molecular mass. We can calculate the mole, so we want to find the mass, and mass is mole times relative molecular mass, because we know that mole equals mass over relative molecular mass. We just cross multiply and we get the mass. So the mass in this case will be 0.1 times that value, and that will give you 1.69. This one will be 0.1 times 186, that's 1.86. 0.1 times 203 will be 2.03 grams. And so the relative molecular mass of hydroxide are not the same. You can see they are different. So we would compare mass of precipitate formed to the expected mass, the theoretical mass in this case.